Very warm welcome to all the participants to this webinar on Israel's circular economy solutions and wastewater management. My name is Patricia Lopez. I am a water infrastructure finance specialist and currently leading the financial innovation team for the water global practice of the World Bank. This webinar today focuses on the Israeli experience in innovation on wastewater treatment and reuse. And we also will hear from some World Bank Group team leaders on how such solutions can fit into a broader framework for driving circular economy solutions and improved water quality at the local, regional, and global levels. Importantly, this session is going to also touch upon what are the enabling conditions for public-private collaboration on this type of solutions and the business case for scaling them and for innovation to thrive. To highlight this webinar is a collaboration of the World Bank Group ITS Technology and Innovation Lab, together with the Water Global Practice, and importantly with our Water Resources Group 2030 team. And before introducing our speakers today, I would like to invite everyone participating to share questions and comments, please, in the chat box, and there will be an opportunity to exchange with the speakers and the discussants later on in the webinar. So, with this, I would like to introduce our first speaker today, Mr. Eli Cohen. Eli brings together more than 30 years experience in nature-based solutions on water and watershed management. And he will be sharing with us some of the highlights from this experience on this type of solutions. So again, welcome, Eli, and over to you to deliver your presentation. Thank you.
Thank you all guys for inviting me here and having me and spending the time to listen to this message that we're trying to deliver for more than 30 years. And it's, I should share it. I know it, let me just say it. Oh, sorry. Can you see that? Okay.
Yes.
Good. So Ayala is the company. We have experience of more than 30 years in this field of sustainability, nature-based solutions. And I'll try to talk a bit about why we need it exactly. And beyond that, show you case studies just to have the feeling that they have the confidence that it can be done. Many people say, okay, where is the technology? And we're talking about nature. And nature can do that. And this is our goal and the belief for many years, and we're actually doing it. And let's just move forward. Over here, you can see this. I mean, the world today is facing two main issues when we talk about environment. One is too much carbon footprint, too high carbon, which we're talking about the climate change, etc. It's mainly because of too high use of energy. And the other one is lack of good water. And most of the technologies that are being used today, actually almost all of them, more or less, are using energy, using chemicals, and demand some kind of maintenance. And technologies tend to fail on maintenance. Many times technologies are good, but when you get into a situation where you need to keep on maintaining it in a high level, then it's failed here and there. And when it's failed, it's a colossal problem. And beyond that, when you use energy, you keep on, the spiral is going up and up, because you keep on contaminating polluting the air and the soil, and we all know the story, hitting the surrounding and adding carbon. And we know that today only 1 or 2% of the sewage, which is amazing, being recycled. And if we want to double it, which is nothing, we need to double the amount of energy that we put into it. So what we're doing over here, we in Ayala, we actually using the power of nature, the laws of nature, the principles of thermodynamics, and we do the job just by using natural elements, which is we'll see it in a minute, which is hydrology. It's plants. It's special aggregates, special additives. And at the end of the day, you can see something like this. Instead of seeing system like this is a system that's doing the same and even better. This one treating mainly organics, sometimes some nutrients. This system treating everything, including heavy metals, pathogens, antibiotics, you name it. Everything is being treated. There is no vacuum in nature. Everything is being used, but just need to design it in the right way. And it can be much bigger, as you see over here. This is a bigger STP, and this is a bigger system, treating much bigger quantities.
I'm sorry to interrupt. Yes. You're not sharing the right slides. Perhaps it's not in the right mode. We are still in the Alexander River.
Where are you now? You can see it moving?
No.
No, Eli, we're still on the first slide.
So let me open it again. Okay. Can you see that now?
Thank you for those of you that have noted this on the chat.
I'm sorry. Yes, can you see that now?
Yes.
Okay.
Perfect.
Thank you. So this is actually the graph, the connection between carbon and water quality. As I said, more water, more water treatment, more energy, and the graph goes out, and it's a never-ending story. And this is the way it can be. It's usually is, and this is how it can be. This is the system that's doing the same and much better, treating all kinds of pollutants, and it's doing it as part of your landscape. And this is a much bigger one. You see, this is a bigger STP. This one treating something like 5,000 cubic meters per day, and it's part of your landscape. We call it the active landscape. And but it's much more than just treating water. When talking about the environment today, it's also about skyrocketing carbon footprint, aquifer contamination, lack of water security, as I said before, aquifer depletion, floodings, air pollution, and etc. And the solution that we give today is all dedicated to one problem. What we're doing in Ayala is giving holistic solution for the entire problem at the same time. You can see this is the architecture of the approach. You see, we're using gravity, as you see over here. We're using the substrates and the plants and special additives to get physical, chemical, and biological filtration all happening at the same time in this system. And this is part of your landscape. And this system also, at the same time, I'll show you in a minute, also harvesting rainwater, treating it, recharging the aquifer in the same time. And there is no energy at all involved here, so we're not creating any carbon. But on the other hand, we actually harvesting carbon from the air. So actually, you see it in a minute. The quotient is the opposite. We're reducing carbon, and by enlarging the green areas, of course. And this is actually the solution. If you think about the world, the only way to change, to reverse climate change is by enlarging the green areas and reducing the use of energy. This is the only way to do it. And nobody, if you think about it, this is because when you manufacture something that is going to use the carbon, it's again you're using technology to do that, and there is a never-ending story because it's keep on using energy to treat energy, so and to reduce energy. So it's a lock, it's a Gordian knot over here. So let's go and see some system that we have designed and did around the world, and this is something that we designed years ago for the city of Nice. Over here, the solution is holistic for the entire Plaine du Var, and we combine a solution for flood prevention, stormwater harvesting, aquifer recharge, sewage treatment, of course, and it all became to be a powerful, beautiful landscape. But I want to speak about something even harder to approach is in New Delhi, north part of Delhi, where we approach where we got a mandate to design a solution for the north part of Delhi. Something like 8 million people living in this area. And right now, and the sewage running freely in the canals to the Yamuna River. And we design a system that actually become to be part of the landscape, part of everyday life, treating the sewage while it's running all by gravity, creating a powerful green landscapes that treat the water and harvest carbon at the same time, no energy at all. We harvest, we stop rainwater upstream, so prevent floods downstream. We treat the rainwater, stormwater, and recharge aquifer by special in charging elements. And of course, it's a beautiful park where people can walk now from the city all the way to the Yamuna, which they can't do in a regular. And these systems are part of it's very social. It's built by the people, built by we are using local commodities, and it serves the people. So this is the only way to keep it alive for a long time. And this is the way it looks. You can see a system that actually looking for many years. People can play golf through it. And this is another system that near neighborhood. This is in Israel, where you treat the sewage over here and then use it for the ornamental pond. There's another one in the mountains down south in India, in the Nilgiris, beautiful, nice school that where we're treating the entire sewage over there. And there are a few systems like this. This is another picture of it. This is something that we have installed in Campeche, Mexico, again, in the city of Campeche for a new neighborhood. But it's not only for domestic water. It can be used for industries and very hard ones. L'Oreal embraced this solution, and they economically they did a very good job, a very good deal. Ahava plant, it's another cosmetic in Israel that deal with this water for more than 15 years. Power plants, again, this one in Israel, working beautifully. This is the water before and after. It's and now this sugarcane factories which are producing very hard water to treat, food plants, cheese plants, textile. It's all been treated by the same technology, and the common thing to all of them, the zero use of energy and zero use of chemicals, all by natural means. And the oils, etc., I won't get into it because of post time getting shorter. But we also design a solution for villages and villagers and all over the world. This is this portable system that you can send it over and install it near any village that today suffer from a lack of good water, and it's being treated by gravity and supply good water for many years to come for these people that today suffer from lack of water. And now coming to rivers that are one of the source of water, but also a source of life in many cities where we have systems that actually treat the sewage as part of the landscape in the city. This is in Yavne in Israel, where we have this wetlands along the river, and over here the idea is to use the sewage water from the nearby STP to treat it and through the polishing and send it to the river. And I think that in this town, I think that the sister STP belong to Aqwise, but I'm not sure, but correct me later, Marc. This is some other river that we are doing now in Israel. It's called Alexander River. It's a very it's one of the main rivers in the center of Israel, getting a very raw sewage from Shechem, from the mountains, very bad water, 25,000 cubic meters per day. And we're treating it using, now it's under construction, using this system that's going to be along the river running into the Alexander River. So what I'm trying to show you here, that the possibilities are endless. It can be done. It not just need to be done in proper way. It can be integrated into our life everywhere, in industrial, domestic, agricultural, everywhere. Become to be part of our life, use zero energy, use zero chemicals, and become to be actually our park and being built by the people and that live in these places. So actually, this is a completely mind change over here, but this is actually the main problem: changing the set of mind of decision makers to make it happen. And as I showed you before, it can be for the private house as well as for the city of of New Delhi, which is the biggest populated town in the world today. So it can be anywhere. And you don't need any conveyance systems. It's a decentralized solution, so you can implement it everywhere, in the city, in the industrial zone. So in the end of the day, it's just we're actually introducing nature back to life, but we do it in an active way, which is working for us in a very efficient way. So I can speak to tomorrow, but anyway, if you have any questions, you're welcome.
Thank you very much, Eli, for this excellent presentation, very illustrative, all these varied range of examples that you provided us. We'll have opportunity to ask more questions later. I really like your idea of built by the people for the people, and really also found, the resource efficiency, particularly in terms of energy consumption, very, very relevant in the context of the climate change mitigation at this point. And good to see some corporates jumping on these kinds of solutions as well in the cosmetic sector, as in this case. But there are others. So thank you. Stay put for the further discussion, the ensuing discussion. I would like to, and we already see some questions coming up in the chat, but I would like to welcome again our second presenter today, Mr. Marc Krieger, who is Vice President for Sales for Aqwise. Also long-standing experience in advanced wastewater treatment and water treatment solutions, and will share some of his firm's experience today. So over to you, Marc.
Thank you, Patricia. I will say in advance that it's hard to follow Eli because he shows wonderful pictures of lots of plants and lots of beautiful gardens. Aqwise is on the other edge of the spectrum with regard to wastewater treatment. We are more focused on conventional technologies. Yes, we are power consuming. Yes, we are generating sludge. Yes, we are treating wastewater in the more conventional ways. There are advantages and disadvantages for both options. It's a matter of scale, it's a matter of land requirements, and if these are available or not. But I will speak a bit about Aqwise in the world of conventional wastewater treatment. In this world, in the biological wastewater treatment world, there are different approaches to intensive treatment, attached growth, suspended growth. We won't go into it, but basically Aqwise works in the world that we call moving bed bioreactor, where we provide optimal conditions for the biomass that consumes the organic material in the wastewater to grow on these carriers, providing large surface areas so we can allow for a large amount of biological activity in small volumes. This is what it looks like when it's operating. All the brown fuzzy stuff are bacteria that grow on the carriers. And this is what's doing the purification within small footprints, parallel to what Eli showed you in his wetlands. So at the end, it's the same result, but with a different approach. Like I said, ours is, yes, it's power intensive, but it is minimizing space requirements, which is very critical to many customers, especially industrial ones, where have space limitations within their facilities for the wastewater treatment units. And also for very large cities where they have to have large volumes and centralized treatment plants, the Mbbr technology allows to do this within a limited footprint. I'll run through, I guess I'll run through very quickly who Aqwise are. We are a technology-focused company that started 20 years ago, that has grown into a global company providing solutions all over the world. Again, I won't go into this because it's not really relevant, but this presentation will be shared with you. We have offices worldwide. We work in both the municipal sector and the industrial sector, providing solutions for new plants, for upgrades and expansions. Our technology is very suitable for taking existing treatment plants and enabling expansion of the capacity or upgrading the performance by applying the carriers into systems that use other technologies. This is very especially important in large cities where they have increasing populations and they have to increase the capacity of their treatment plants. And by applying the Aqwise technology, you can do this without needing additional civil works and additional land allocations, which in urban areas is very expensive. So this is what we do. Municipal solutions, retrofitting existing plants, and minimizing civil works. The same in the industrial sector. And we work with industries that have high capacities of wastewater, like pulp and paper plants, like food and beverage factories, where the flow rates are very high, the organic loads are very, very high, and need special attention in order to reach the effluent requirements required by either the environment or the local sewage treatment plant that will accept the treated effluents from the industry. So again, these are energy intensive processes that use a lot of electricity. They generate sludge, but they do allow industries in large cities to meet their effluent wastewater treatment targets. Customer benefits. Our plants are very small in their footprint, and this is very important to many clients, especially large cities. For example, the city of Hong Kong, because the value of real estate in Hong Kong is so high, they are willing to pay a lot extra to minimize the footprint of their sewage treatment plants because the alternate value of the land is much higher because they build on them high-rise buildings. So in dense urban areas, our technology provides advantage, and also to industries which have limited space for wastewater treatment, they can apply this efficiently with our technology. Aqwise works in different models, but this is not relevant maybe to this discussion, but we can work in different models, and we have been involved in the past in a number of World Bank projects through third parties where we have provided our technology, but we can also provide financing, we can provide also turnkey capabilities. We have our own in-house R&D facility where we are always developing new ways to apply our carriers and our technology to the increasing spectrum of pollutants. They can be from the pharmaceutical industry, from groundwater pollution with industrial chemicals. And we are always advancing our knowledge so that our technology can be applied to all these new challenges facing us in the world of wastewater treatment. Just a few examples of how we apply our technology and what we do. Maybe this is probably the most sample. This is the project that we are most proud of. We're back in India again. The Yamuna River basically collects all the treated or partially treated effluents from the city of New Delhi, which Eli mentioned before. And if you flow with the river 200 kilometers downstream, you'll reach the city of Agra, home of the famous Taj Mahal. And the Yamuna River is the source of drinking water for the people of Agra. And because of the increasing levels of contamination in the river, because the local treatment plants don't work very well, they had to upgrade their water treatment plant in order to continue to provide safe drinking water to the inhabitants of Agra. And Aqwise, together with a local Indian engineering firm, provided a solution using our carriers with our technology that could allow taking contaminated river water, which is basically diluted sewage, and bring it to a level where it could eventually be meet drinking water standards and provide drinking water to the population of Agra with minimal chemical use and high quality and consistent performance. We're very proud of this plant. It's very well known in India and something that we think can be applied in many places around the world to treat contaminated water, river water to drinking water quality. Another case where we apply our technology for drinking water applications this is a case in Israel, and we know that these conditions prevail in many places around the world where groundwater is contaminated by nitrates or nutrients that come from intensive use of fertilizer. So we use lots of fertilizer for our crops, and we irrigate the crops, and eventually the excess ammonia or nitrogen and phosphates percolate into the aquifer and disqualify large amounts of groundwater from being used for drinking water because of the contamination. And we apply our technology to remove nitrates. Nitrates, for those of you who are familiar, are what cause what's known as the blue baby syndrome. And reducing the nitrate levels allows us to make contaminated aquifer water into safe water for drinking. This is a project that we have applied in Israel, and it can be applied in many places where this problem is prevalent. These are more common conventional treatment plants. This one in Shaya in northwest China, where we are treating the water to provide effluent quality that is used for irrigation of fruit orchards around the treatment plant. Another project in India, this is a treatment plant treating effluents coming from an industrial park. And by applying our technology, they could improve the performance of the existing plant and allow its expansion of its capacity. So this is all variations on the same thing, where applying our technology allows expansion of existing plants without needing to do additional civil works or using additional land in Thailand, in Mexico, and upgrading effluent quality so they can be reused either by agriculture or by industry. Samples also from industrial applications. This is an apple concentrate factory in Poland. The wastewater is very, very concentrated, very, very high strength, and we apply our technologies to generate biogas from the wastewater, which can be reused by the factory for either heat generation or electricity generation. So again, the applications are wide. In many places, industries pay high surcharges to the cities for discharging high-strength wastewaters. And at some stage, investing in in-house treatment in order to reduce their fees to the city becomes cost-effective. And we can do this very simply and very efficiently. So basically, again, we work in all this realm of high-strength wastewater. Another application is the field of aquaculture. The industry of aquaculture is blooming all over the world to grow locally on land fish and seafood. And these systems require recirculation of the water so that the fish can continue to grow without replacing the water in the ponds. And this is something that is expanding all over the world. And our technology can be used to enable the fish growers to use the same water for extended period of time without replacing it. And this is, of course, very beneficial to their industry and also to the water balance in the environment that they're working in. So this is what we do. Like I said, we're more or less at the other end of the spectrum compared to what you saw before from Ayala. But that's okay, because there's work for everybody and there are applications that are suited for all technologies. But this is what we can offer. And we're happy for the opportunity to share it with you. So thank you very much.
Thank you, Marc, very much for the presentation. And indeed, you know, there is a good solution for every case, and you gave us many examples from many different places around the globe. Just a very quick question. I saw someone posted in the chat, which you can clear straight away. Someone was asking whether the technology you use is Mbbr.
The answer is yes.
The answer is yes. Thank you very much, Marc. And please stay put for further questions later. You know, you highlighted the space requirements and then the small footprint of some of these solutions. And I also wanted to highlight, you mentioned the simple or easy operation and maintenance. I think this is is a very relevant feature in many of the projects we work on at municipal level, where the capacity is really a constraint in terms of really being able to operate and maintain complex wastewater treatment facilities. Thank you, Marc. And now I would like to introduce and give the floor to one of my colleagues in the World Bank, Midori Makino. She's a lead water supply and sanitation specialist. And basically for some reflections as well on these presentations, and to let us, to talk to us a little bit of what the water global practice approach to circular economy is at the moment and some of the ongoing initiatives. So without further ado, over to you, Midori, and welcome to the webinar as well.
Thank you, Patricia, and thank you very much for the invitation. I was very inspired and encouraged to listen to this earlier presentation. I would like to hear just project just one slide that I wanted to see, which will illustrate the wiser framework, which I'm part of this team which developed this framework at the World Bank recently in response to the current or the conventional linear thinking, which was, take, make, consume, and waste approach. We really wanted to shift our mindset to encourage our clients to think more in a circular form, to really capture the full value of water. And this is highly relevant to the, what the earlier presenters were the points that they're making as well. This wiser framework has 3 outcomes that we really want to achieve, and those are in the outer layer in the green. The blue text following that layer are the
Midori,
yes.
Sorry for interrupting you, but
yeah.
I do see your slide, but some of our participants cannot see it. Maybe it's not yet on presentation mode. Could you just double check, please?
Okay. I hid the presenter view. Does that help?
Yes. Hopefully this has solved the problem.
Okay.
That's better now. Thank you.
Okay.
We can see it well, Midori. Thanks.
Thank you. So just to show you this wiser framework, the green, let me just quickly go through the 3 outcomes and what actions we're proposing. For the first one, which is to deliver the resilient inclusive services, we propose planning for climate and non-climate uncertainties, maximizing the use of existing infrastructure, and also diversifying the water supply sources. The second outcome on designing out waste and pollution, we're suggesting to be energy efficient and maximize the use of renewable energy. And we also to optimize the operations, for example, by reducing non-revenue water. We should also recover resources from water and reuse them in the form of treated wastewater, fertilizers, and energy, and so on. Now, finally, we have the third outcome on the preserve and regenerate natural systems. Here we're proposing restore degraded land and watersheds, recharge and manage aquifers, and incorporate nature-based solutions, which is very central to the first presentation. In order for this to work, we also propose that 4 or 5 cross-cutting areas be focused at the same time. And those are to manage water demand and also to leverage potential digitalization and technology, creating the right policy, institution, and regulatory framework to foster the circularity and resilient solutions. Also to incentivize the adoption of this approach through financing, and not to forget the vulnerable population to really to be inclusive in the solutions so that we, there's going to be a benefit to everybody. So the key takeaways from this study, which this follows our earlier study, which focused mostly on the wastewater reuse, we have now created this entire cycle of the circle of water from, all stages of water. And applying this framework, we realized that it's not only a benefit to environment, but it actually has benefit to social, economic, and financial aspects as well. There are also cross-sector linkages, very strong linkage with the energy sector, the urban, the environment, agriculture, so we have to work together. I also wanted to point out to demystify the common perception that this is only applied to, richer countries or higher income countries. It's not affordable, the technology and so on, but it's actually not the case. We've seen cases, as the earlier presenters also showed, this could be applied also in lower income countries. And tying back to the presentations I saw earlier, I really think that it is important to have this partnership with the private sector and the innovation to really leapfrog from the current status, because of the very high, ambitious sustainable development goals and the country goals. We are seeing a lot of countries are really struggling to reach their targets with the conventional system and the existing financing. So this type of partnership to really, change the way we do business, this is highly welcome, and we really look forward to, partnering more with the private sector and bringing more innovative solutions. So this is my intervention. So I'll be happy to take questions as well. Thank you very much.
Thank you, Midori, for this really succinct but very effective presentation of the WISER framework, and also for your messages on the collaboration with private sector. I'm sure there will be questions to you later as well. I would then like to introduce and hand the floor over to Michihiko Ogawa. Is an investment principal with the IFC, Michi, over to you to also share your reflections on this on the topic of this webinar, and also some of the ongoing initiatives by the IFC and the broader World Bank group around collaboration with private sector and wastewater treatment. Welcome again.
Thank you, Patricia. I hope that you can see the slide.
Yes, we can see it, Michi. Thank you.
Okay. Good morning and good afternoon or good evening, everyone. So my name is Michi Ogawa, and I'm working with the IFC Infrastructure Department as an investment officer.
Sorry, Michi, we can see your notes.
Oh.
Like
thank you, Michi. And you saw I just promoted you in my introduction, so I hope you don't have any complaints for that.
Yeah, sorry, did you say that you can see my note? Is that right? I don't know how I can deal with that, but
yes.
Well,
on display settings.
I think you can go to the three dots and select, and select hide presenter view.
Yeah, that's
and go
good
to press the presentation. Yeah.
This one, right?
Yes.
Can everyone see the screen?
It's
yes,
just
we
not
see
a full screen,
but not yet on presentation mode.
I mean, apologies for this technical issue, but let me, go with that, for the sake of time. And I also taking the opportunity to thanking, you for inviting me for this interesting session. And I also like to thank Ellie and also Marc for their very interesting technologies. So at IFC, we are trying to bring in private sector investment and also private sector technologies and know-how in order to enhance or increase the wastewater coverage globally. So in the meantime, we appreciate that there's also challenges in deploying, wastewater globally. The first challenge being the low affordability or the low willingness to pay. So as you know, in many countries, there's low willingness to pay for the wastewater services. And as a result, tariffs are low and they are heavily dependent on subsidies. Another challenge is the bankabilities of those wastewater sector projects. So in most of the cases, utilities who is running those utilities are not creditworthy. And at the same time, a wastewater project, depending on a project, but it's also fair to say that the size tends to be small. So as a result, I think that in terms of the BOT or PPP type of project, it has not been as many as we have seen in desalination or clean water sector. And at IFC, we like to increase those opportunities for BOT and PPP project in deploying wastewater. So that is why we have been launching the new initiative called Scaling the Water. The Scaling the Water is an IFC and also a wider World Bank product, which is a packaged solution, especially for the utilities. So this contemplate with a transaction advice to the utilities who is willing to develop the wastewater treatment works on a PPP or BOT basis. And we have also a preset of project documents, which can attract competitive financing and also international sponsors. We are also trying to design a hybrid financing because, as I mentioned, there's a lot of public resources, putting into the sector. And I think that in many countries, public financing is still needed. And at the same time, to address the low creditworthiness of the utilities or the off-takers, we're also working with the World Bank Group in order to come up with some risk mitigation, risk management product. So those are the what we are doing in the Scaling the Water initiative. And I don't go into the detail, but we are developing template, project agreement, and we are also developing a pre-qualification document or RFP, so that we can have a balanced, risk allocation between public and also private, and attract a private sector investment. Okay, so that's all from my side. Thank you, Patricia.
Well, thank you, Michi, for this brief but really good overview of the Scaling the Water initiative. We are all very excited, and we hope this will be of good help also to the World Bank teams working on these kinds of projects. So thank you for being here today. We have some 15 minutes now for discussions and questions and answers, and we'd still like to hear from the organizers from our Water Resources Group 2030 team as well, to reflect a little bit and to share with them their experience with some of their country platforms to promote these kinds of solutions. But so let me just go to the chat. We have, very active comments and questions from the participants, a lot of curiosity around the presentations, and some questions first, maybe for Ellie. And, we won't have time to answer all of the questions, but we promise to share them with our speakers and discussants, and perhaps get back to you in some way with these questions. First one, Ellie, for you on the flood mitigation, which you mentioned, and how can these natural waste treatment approaches also address flooding? If you can get started with that, there were also questions whether the plants grown are edible, and some words of appreciation and encouragement over to you. So again, another question on how the system can handle heavy floods. Would you go ahead and comment on that?
Yes, I'll do. I mean, floods is not a God gift. It's a man-made action, actually, today, mainly in the urban and the industrial zone because of too much paving of the environment of the land, and at the same time cutting reducing the greenery that actually hold the water, used to hold the water in the past. So when you have a rain or have a monsoon, wherever it's happened, water just flowing fast to the lower point and create floods. Again, this is a man-made contribution. And what we're doing, we're going upstream. We fabricate the city in this case, or industrial zone, or even in the agricultural zone, with many small systems that treat sewage from distant sources. We also do it on the roof, for example. When we hold the water in many places and don't let them run in one shot to the bottom line, to the bottom to the lower part, then we reduce dramatically the chance of having floods. Floods happen when a lot of water coming in the same time to a bottleneck and just clog there. And when you stop it upstream, then you can prevent it. And we're doing it while we also treating the water. We charging part of the water to the ground. We treating sewage in the same places, and it's all as part of a holistic approach and design. So this is about flooding. Yeah.
Eli, another question for you. What is the incentive for a municipality, for example, to invest in these kinds of solutions, which can be comprehensive to address a number of problems, versus, you know, the charging for a sewerage, conventional sewerage service fees?
It's a very good question, because, you know, in my farm over here in Israel, all the water has been treated in my farm, but I'm still paying the municipality for treating the sewage, which I'm not sending out. So it's you're right. The municipalities want to charge you for your water, for your sewage, because this is part of the income. And you're right. For the long run, there is no incentive. But if leaders will make the right calculation for the long run, they have a huge incentive, because the saving for the long run is huge. By doing it, by treating the water and recharging the aquifer and supplying good water. Otherwise, they will have to bring water from outside somewhere, and the cost will be much higher later on. So you need good leaders that understand the incentive at the end of the day.
Thank you. This was a very good question by Peter Maniara, and we have some questions also for Marc. Okay, we have, you can see in the chat, what is the requirements in terms of energy consumption, kilowatt hour per cubic meter. I'm not sure if you can be so specific in your response. Also, can this achieve CLD, zero liquid discharge? Is this something you feel can be answered straight away, Marc? Another interesting question here from Mr. Kalu Haniti would like to know if Aqwise works in repurposing the existing conventional activated sludge process-based wastewater treatment plants to Mbbr. I think you have enough there, Marc.
Okay, we'll take them one at a time. The first question is about energy requirement for wastewater treatment. It's obvious that the energy requirement to treat wastewater is in direct relationship to the load of the organic pollution in the wastewater. The higher the load, the more energy you need to purify it with biological processes, with aerobic biological processes. Municipal wastewater, which is more or less standard in most places around the world, will take between 0.8 and 1.0 kilowatt per cube, depending on a number of parameters like the depth of the reactor, the type of diffusers. This is all engineering stuff, but that's the range for municipal wastewater. Industrial wastewaters obviously will vary. Wastewater from an ice cream factory is not the same as the wastewater from a textile factory or a pulp and paper factory. And there, the energy requirements will vary depending on the organic load coming from the plant. So it's not a standard answer, but it can be determined on a case-by-case basis per the project. Regarding the zero liquid discharge, obviously zero liquid discharge systems, which are required now of many industries in a number of countries, comprise of a number of treatment stages. And the biological treatment, which is the Mbbr, can be part of the ZLD system. So there will be conventional biological treatment, and there will be solid separation, and eventually it will go to reverse osmosis for purifying the water, and evaporation to reclaim the salt. So it can be part of the ZLD system, but it's not by itself a zero liquid discharge, because the water that goes into the Mbbr comes out. But it can be followed, or it can be part as a pre-treatment stage to the stages that do the zero liquid discharge or the reuse. And we do have a number of cases where our system is part of ZLD system in an industry. The last question was regarding conversion of activated sludge to Mbbr. Yes, we do this quite a bit. Like I said, converting an activated sludge plant to Mbbr brings a number of advantages to the client. One, it allows them to increase the capacity of the plant within the existing infrastructure. So by taking activated sludge plant and converting it to Mbbr, you can increase the capacity within the existing tank by 30, 40%. So this is obviously something that is very desirable to clients that have to expand their capacity. And also it enables to achieve improved quality, either by nutrient removal or other things. These are things that basically can be done. They are looked at a lot now in big cities which have to upgrade their plants. And yes, we have many opportunities in this specific application.
Thank you, Marc, and I'm sure there's a few other technical questions like that encourage participants, and thanking them for the questions, thanking all of you to address Mr. Cohen and Marc, also offline to if you want to get satisfied on other technical specifications. I want to reflect that one of the key interests for the World Bank group is how really we can scale up good examples like the one you shared with us today, and what can the public sector do more of to adopt these innovative technologies, and what also ensure a level playing field for innovation to continue, and for this collaboration with private sector to continue and to thrive. Here, of course, I would love to hear from all of you and from all our discussants as well, but I would like to invite Rocky Kenka, who was a key person in putting together this webinar from Water Resources Group 2030 to maybe reflect on this question, Rocky, and give us some flavor from what the multi-stakeholder country platforms can do to this regard.
Thanks, Patricia. And, this is a key question, is always, how can public sector work with private sector? And this is something that 2030 Water Resources Group, we've been driving through our multi-stakeholder platforms at the country and the state level. And really what these platforms do is create a pre-competitive space. So working upstream of transactions to unlock a series of different projects and initiatives, but getting public sector, private sector, and civil society to sit around the same table and innovate on the design of such solutions, right? So that's really what the model has been. And the pre-competitive space then allows for different types of solutions to come out. So it's not the same solution in every context. It really depends on the specificity of that context. So for example, through these platforms, we've been able to look at different PPPs being structured around the world. So in Mexico, in India, working jointly with the World Bank and IFC, for example, on the Ganga Basin, but also in Brazil, in Bangladesh. So different country contexts, but how do you get, a series of PPPs, public-private partnerships unlocked, which target entire geographies, entire sectors. So that's been one sort of key potential for the platforms to unlock, and looking at the potential for replicability from day one. So not trying to retrofit, scale after the fact, but how do you design initiatives where scale is really, the main intent. Another example is sort of, how private sector can engage also in the policy space. So for example, we worked around water pollution laws and how, for example, polluter pays principles can drive, greater engagement of private sector, encourage more pretreatment as well as greater reuse. So, this is another example where a policy space can create room for innovation and technology to come in, both from the perspective of private sector as users, as well as private sector as innovators and technology service providers. Let me give a third example, which is something which we've recently come up with called wastewater reuse certificates. So we've all heard of carbon trading, emissions trading, but it's never really been tried for wastewater reuse. So this is a concept that we've developed, which looks at a systems approach and sets targets for different wastewater generators or water users. And depending on whether you're meeting those targets or not, either you're getting credits in the form of wastewater reuse for targets exceeded, or you have a shortfall and you can purchase wastewater reuse certificates to meet those targets. So again, it's an opportunity to drive greater reuse, more circular economy solutions, and get engagement from the private sector. So just to sum up, I think there is not one, prototype of a solution to level the playing field, but engaging with private sector, government, and civil society from the very beginning helps to unlock a combination of technology, policy, finance, and really the enabling environment for solutions to thrive. Thanks.
Thank you very much, Rocky. And, this is a fascinating subject. I wish we had more time to keep discussing, but this means we'll have to do more of this. We keep, getting some comments from the participants as well. For example, on whether there are good reports that compare actually the various existing models for creating water sanitation assets and operation and maintenance based on PPP modalities like DBO, BOT, or hybrid annuity model. We can refer participants to some resources, but otherwise, it's something that we can endeavor to work on for the future in terms of facilitating some resources to World Bank teams. Rocky, actually a question for you about the water reuse policies and whether there is any overarching guidance document from WRG 2030 for provinces to create water reuse policies. This is very specific to India.
So we don't have a specific document on the reuse policies, but happy to follow up after this call with some details on the work that we've done. The handbook on the wastewater reuse certificates idea that I just mentioned is publicly available, as are various other resources from the country context on our website. So I'll post the website link in chat for whoever's interested. Thanks.
Thank you, Rocky, very much. And I guess we are heading now towards the closing. I would really like to thank very much our speakers today, Ellie Cohen from Ayala Water and Ecology, Marc Krieger from Aqwise, and our discussants from the Water GP and the IFC Water Resources Group. Also like to thank Ari Haliva from the State of Israel, Sigalit Lidai, and Beret Mitzari, apologies, from the Startup Nation Central. And of course, my colleagues Midori, Makino, Michihiko, Ogawa, and Rocky Kemka for the insightful comments.
Patricia?
Yes, Marc? Yes?
Yeah, before we end, I know I will allow myself maybe to speak also for Ellie, but we would appreciate if you could share our presentations to all the participants and provide our contact details. I think Ellie will agree that we are both available to further discuss and to answer questions and to be involved as required in any of your future activities in the various World Bank Group sectors to support with each one with their own technology and where it can be applied and how, and involvement in the PPP arrangements that were discussed earlier. So I just like to share that we are available to answer any further questions, and please share our presentations.
Sure,
Thank
good
you.
point, Marc. Thank you. Please do that. Thank you.
No, thank you both for that offer, and you can count that there will be some reach out to you on this regard, and we'll share the presentations as the colleagues were indicating at the beginning, and your contact details as well, in case some of the colleagues would like to approach you directly with specific questions. Again, thanking everyone for the participation today, and particularly the ITS team and the 2030 Water Resources Group for taking the leadership in putting this session together, and from bringing Ellie's and Marc expertise to the table. And indeed, again, to Midori and to Michi for talking to us about what's going on at the World Bank Group level. And we shall stay in touch.
Thank you,
everyone, for participating.
Thank you.
Thank you.
Thank you very much.
Thank you.